we've only had two. Now we're going to introduce a third thing to worry about. All right, this time I always find it helps just to draw a little diagram, right? Some of you are really good at picturing things, but I always think it really helps to just draw a little picture. So this is a balloon. And there we go. And it inflates at a rate of 150 centimeters cubed a second. All right, so we're blowing it up with helium. I want to know what is the rate of change of the surface area when R equals 6. All right, so what I'm going to do is think about what I need to find out. So let's first of all write an equation. So what do I need to find? The rate of change, which is what? Rate of change of what? The surface area. So how do I write my equation? dA over dt. Good. All right, so I've got dA over here as normal, and then I've got dt over here as normal. What do you think is going to go in here? Okay, so this is actually a little bit trickier.
Yes.
dV.
dV. Because I'm interested, so I'm being told that the volume inflates, right? The balloon is inflating at a volume rate. This was cubed. The problem is I don't have enough information to do this at the moment. So I'm going to have to break one of these down. So let's try and do that. So first of all, let's start with the things that we do know. What do we know about spheres? Surface area is 4 pi r squared. So then we've got dA dr, and that is
8 pi r.
8 pi r. All right, let's change color and do the other thing we know. We also know volume, which is
4 by 3 pi r cubed.
pi r cubed. So then dV dr is
4
good, 4 pi r squared. Now, the thing is, dA dr and dV dr appear nowhere in this at all. But this is the information we have available to us. We can't get dA dV or dV dt. We don't know these things. Sorry, we do know this one, don't we? We know that. The rate of volume over time is this, right? So we know that this is that. But we need to use both of these things to actually get this. So I'm going to write another little formula. I'm going to break, oh, what? No, I don't want to do that. I'm going to break this into something else. I'm going to say that dA dt, actually, no, I'm not going to write it like that. I'm going to say that dA dV is dA over something times something over dV. And the other thing we have is R, right? So we've got dr. We can add that in over here. And this together is going to become that, right? So together, this is turning into that. Do you see what I've done? Okay, so let's try and do this. dA dr, do we have that? Good, we've got that up here. We said that that was 8 pi r. Do we have dr dV? What? It's the inverse. This is dV dr. We need dr dV, so it's actually 1 over 4 pi r squared. This is the bit that everyone screws up, okay? So just make sure you know which way around the fraction is. We need dr dV because these have to be opposite, but we got dV dr. So this is just 1 over that. Now we can simplify that. Okay, so now we've got 8 pi r over 4 pi r squared, which is 2 over r. Okay, so we've got 2, what am I doing, over r. All right, let's go back, zoom out a little. Let's go back to this. So now we have this, right? So if we go back to the highlighter, this is that now. Okay, so I now have, this goes over here, we've got 2 over r times 150. That was the rate we were given in the question, right? Yeah, 150. So now what do I need r to be? 6. So I've got 2 over 6, which is 1/3.
Is 15.
Yep. I'm actually just going to write that the whole thing so I don't confuse anyone. This is 2 over 6, which is 1/3. So 1/3 of 150 is 50. So what units of measurement were we in before? What are we in?
Cube per second.
Okay, so what am I finding out here? The rate of what?
Okay, the surface.
Surface area over time.
Square.
Okay, so this is going to be centimeters squared per second. Now, these questions are really hard. When we have 3 variables, it gets really, really tricky. There aren't too many of them. There's often, well, sometimes there's none of these on the exam. Wouldn't that be nice? Sometimes there's one.